Welcome back to the deep dive. Today, we are strapping on our virtual safety harnesses and stepping into the highly specialized and actually surprisingly high-tech world of industrial machine safety.
It's a really fascinating area.
It is. We're diving deep into what the industry calls presence sensing safety devices,
Yeah.
or PSSDs.
And this is a field that sits right at that intersection of, automation, engineering, and human life. The sources you share, they detail everything from light beams to 3D radar.
Right.
And they really show that this isn't just about painting lines on a floor. It's more like building an electronic immune system for a factory.
Exactly. Our mission for this deep dive is to map out these complex safety technologies. We want to draw the crucial distinctions between 7 different PSSDs and give you a shortcut to understanding the tools that keep heavy, fast-moving machinery from turning into a catastrophic hazard.
Fundamentally, that's what it's all about. PSSDs are proximity-based devices. They are the frontline electronic defense engineered to ensure human operators maintain a verified safe distance.
And what's crucial here, and this really stood out to me, is that these aren't just for brand new factories. The sources highlight their importance in enhancing legacy machine safety.
That's a huge point. For facilities that can't just scrap massive functional machinery, these PSSDs bolt on modern high-integrity safety measures.
So they're a modern solution for older problems.
Precisely. They are engineered for modern risk reduction programs, specifically focused on preventing unexpected motion or machine restarts, and of course, continuously monitoring that safe distance.
Okay, so let's unpack this. These systems have to integrate with the physical world, right? With fences, access gates. How do PSDs provide that critical electronic layer?
Well, they establish an invisible smart boundary. PSSDs handle the electronic surveillance that complements the actual steel structures.
So their goal is twofold.
Essentially, yes.
Yeah.
First, active restart prevention. It makes absolutely certain the machinery cannot spontaneously fire up if a person is in the area.
And second,
They enforce controlled access. They monitor that boundary line, ensuring that if power is applied, no human can cross into the danger zone.
let's start at the most basic layer of detection then. The technology is purely focused on just sensing presence. I think the most common system we see is the safety light curtain.
The light curtain is foundational, yeah. You have to picture a dense array of infrared light beams stretched across an opening. It's like an invisible, hyper-responsive digital fence.
And the source material describes them as slim, durable.
Exactly. Perfect for high-throughput cells or machine guard openings. And they are extremely fast.
So if someone breaks a beam, the machine just instantly stops. That sounds simple enough, but what's their drawback?
Rigidity. Their drawback is their rigidity. They are fixed beams in a fixed line. They work perfectly for standard, pass-through areas, but they offer zero flexibility.
So if you need to monitor an irregularly shaped area...
You need something smarter. Yeah, if the safety boundary needs to change, you need a different technology.
Which brings us to the safety laser scanners. I find this concept so interesting because it really injects customization into this field.
It absolutely does. The key feature of the laser scanner is the ability to map out and really customize detection zones. You can program the exact shape of the safety zone on the floor.
Anything from a circle to a U shape?
Anything. The sources describe them as compact, network-ready, and highly reliable for wide area safeguarding.
Okay, so for you, the listener, who might be comparing these systems, why choose a complex laser scanner over just a few simple light curtains? What does that customization really buy you?
It buys you efficiency and flexibility. Let's say you have a robot in a large cell. A light curtain just gives you a binary in or out.
Right.
A scanner lets you create a warning zone first, a slowdown zone, and it only stops the machine completely if someone enters the inner critical zone.
Ah, so it minimizes costly production starts.
Exactly, while still maintaining safety integrity across a much wider and more complex area.
And then, bringing it right back down to the factory floor, we have the most fundamental system of all, the safety switch mat.
The molded safety mat. It is the simplest concept, really. It detects presence because an operator is physically standing on it. It's just an electrical switch triggered by pressure.
It sounds a bit low-tech compared to lasers. Why is it still so essential?
Because of its reliability and its very specific function. You can't stand on a light beam.
Good point.
The mat guarantees detection right at the floor level. And crucially, the sources specify these mats resist oil, debris, and wear. They're built for the factory floor.
Here's where the challenge of that industrial environment really becomes apparent. Light curtains, laser spanners, they're fantastic, but they can be easily blinded by dust, steam, things like that.
Absolutely, the harsh realities of manufacturing.
So let's look at a technology designed specifically to overcome those issues.
That gap in environmental resilience, that leads us directly to the 3D safety radars by Inspect. This is not a vision-based system, it's adaptive radar.
Okay, radar. So what exactly makes them so resilient?
They use radio frequency signals, not light. So the source notes, they're explicitly designed to be resilient to, heavy dust, steam, light, flying debris.
So in a woodworking shop full of sawdust or a food plant with constant washdowns?
The radar senses human presence accurately, regardless of what's in the air.
The specification for this is genuinely impressive. We're talking a configurable field of view, or FOV, of up to 9 meters.
It's a huge area. That means you can map out a robust, wide safety zone that's virtually immune to interference. You get radar-level certainty where optical sensors would fail.
It's the high-integrity solution for the high-mess environment.
That's a perfect way to put it.
Now, let's pivot from simply sensing proximity to actively controlling access. These are the interlock devices.
Right.
These aren't just sounding an alarm. They are about making sure the machine itself validates the safety condition before it physically lets someone in.
This is the shift from passive detection to active control. And we're looking at 3 highly specialized interlocks here, starting with a kind of mechanical electronic hybrid, the trap key interlock safety switches.
That sounds intriguing. How does a key control access to a hazard zone?
Think of it like a safety checklist that's physically enforced by a key. The system locks out a hazard zone, and the key needed to open the barrier is electronically or mechanically trapped inside the system.
Trapped until when?
Until certain safe operational sequences are fully completed. Things like ensuring the motor has spun down to 0 speed or all hydraulic pressure is vented. Only then is the key released, allowing access.
So it's procedural control made rigid. You can't skip a critical safety step.
Exactly. It guarantees the safe sequence is followed, which is invaluable for complex maintenance procedures.
Moving into the purely electronic realm, we have 2 types of high-tech RFID safety switches. The first is the RFID safety switches, non-locking.
These are all about high integrity and electronic sophistication. They use inductive sensing, a clean, non-contact way to verify a barrier is closed.
And they have some serious technical pedigree, right? The sources mention they achieve Cat Force IL3 capability.
They do. And for listeners who don't live and breathe safety standards, that level of certification is a big deal.
So how does that translate into real-world confidence?
Think of Cat Force IL3 as the industry's highest reliability rating. It essentially guarantees an exceptionally low probability of this device failing dangerously when you need it most. It's the highest tier of electronic dependability.
They also boast an IP69K housing. That sounds like extreme protection.
It is the extreme environmental rating. IP69K means protection against dust, but more importantly, against high-pressure, high-temperature washdowns.
So built for food processing or pharmaceutical plants.
Environments that would destroy standard electronics very, very quickly, yes.
And finally, what's the crucial distinction of the RFID safety interlock switches locking version?
The locking version adds a physical layer of security. Its specific function is to secure machine access doors until a verified safe condition is met.
So the system confirms 0 energy or 0 movement.
And only then does an internal solenoid release the physical lock on the barrier. It prevents human impatience or error from overriding the safety protocol.
It's fascinating. The source even provided a specific price for this, $466.20.
And that speaks volumes. You're not just buying a switch, you're buying the integrity of that lock and the assurance of that SIL3 rating.
What's really striking here is how detailed and rigorous these technical specs are. It just shows the high-stakes nature of this field.
It really does.
Let's maybe synthesize the most critical jargon for the listener, because understanding these standards is the key takeaway.
This is the so what on the tech specs. We saw the safety levels, Cat 4 Panel 3 on the RFID switches. That rating is paramount because it ensures reliability, even if there's an internal system failure. If one component fails, the system must still fail safely, meaning it shuts the machine down instantly. That's the promise of SIL3.
So if you're integrating a new safety system, you use Cat Force IL3 devices to ensure maximum risk reduction.
Precisely. We also saw the environmental ratings, IP69K, that confirms these electronic guardians can withstand the most aggressive factory conditions. Safety components have to be as tough as the machinery they protect.
And finally, let's revisit the power of customization.
Right, the ability to customize detection zones with the laser scanners and that highly configurable FOV of the 3D radar reaching up to 9 meters.
So it's about tailoring the safety response.
That's what separates modern safety engineering from just, putting up a standard fence.
Yeah.
Safety has to be adaptive.
So what does this all mean for you, the learner? The sources confirm that ensuring safety isn't just about a physical barrier, it's about stacking multiple specialized electronic defenses.
From simple pressure mats on the floor to sophisticated 3D radar that cuts right through interference.
It's the combination of passive intrusion detection systems, like the light curtains,
With high-integrity, active control systems, like the trapped key, and locking RFID switches. Understanding this gives you a shortcut to modern, layered industrial risk reduction.
This also brings up a bigger engineering challenge. We've talked about 7 different types of devices: sensing, locking, radar, and they all have to interact. How complex is it to link them all into one cohesive safety system?
It's an immense system integration hurdle. If the 3D radar detects presence, it has to communicate that state instantly to the main control system.
Which then has to check the state of the RFID switches.
Yes, verifying the entire system's integrity. The complexity lies in that seamless electronic choreography between all these disparate devices, all at millisecond speed.
System choreography is a brilliant way to frame it. So to wrap up, we've covered everything from the foundational safety of light curtains to the environmental resilience of that adaptive 3D radar.
And we focused on the crucial distinction between devices that merely detect presence and those that actively control access, ensuring safety through sequenced protocols.
Like the trapped key interlocks and those high-integrity Cat4Cell3 rated RFID switches.
Right.
If we connect this knowledge to the bigger picture, the fact that the industry is relying on these advanced devices, which secure doors until a verified safe condition is met, it raises an important question for you, the listener.
And that question is, what specific, measurable criteria define that verified safe condition for different types of heavy machinery?
That's the next layer, isn't it?
It is. Is it just zero speed? Is it confirming zero hydraulic pressure in a press? Is it monitoring a specific temperature in an oven? The definition of that safe condition is the critical, measurable next layer of complexity.
A powerful point to mull over. Thank you for joining us on this deep dive into the specialized world of presence sensing safety devices.
Until next time.
Stay safe and stay curious.